A very good afternoon and a warm welcome to one and all present here. This is Aditi, your host for today's guest lecture session. This is the second lecture of our guest lecture series of the Techno Management Fest of IIT Patna, Celesta. This year, Celesta is being conducted in a hybrid mode with our guest lecture series continuing to be online. So call out your friends and get glued to the screens. Today, we have with us Shri Prateek Kishore. He is an outstanding scientist and director at Terminal Ballistics Research Laboratory. He has made significant contributions in the area of research in design and development of shaped, charged, and explosively formed penetrator warheads. He was also involved in the development of first prototype of pulse detonation engine in India, leading to its dynamic trials under laboratory conditions. He has published more than 35 papers in national and international journals, conferences, workshops, and holds 2 patents. For his technical contributions, he has been awarded with DRDO Young Scientist Award in 2002, DRDO Scientist of the Year Award in 2011, and DRDO Award for Path-Breaking Research, Outstanding Technology Development in 2007, and also Special Award for Strategic Contributions in year 2009, 2012, and 2016. That's a huge list of achievements, sir, and Team Celesta gladly invites you to our guest lecture series. Handing over to you.
Thank you very much. Now you can share the presentation. It's really an honor and privilege actually to be talking to the youngsters, the young generation who I feel will be the technocrats who will be taking the research and development areas in times to come. I would be this opportunity I will take basically to just present the challenges that we have in defense R&D field, and whenever the challenges are there, the opportunities are galore, and that is what exactly our purpose of apprising the youngsters are, that the defense technologies, and when we talk in terms of defense technologies, the self-reliance comes automatically. So one with the recent events that are happening in various countries across, you can see that at some point in time, having control on technology is absolutely a must. We can have willpower to fight, we can have means to fight, but it is ultimately the technology which also determines the outcome. So with this background, I would just go into a presentation. I would try to complete it in about 35 to 40 minutes of time, and then we can have some interactive sessions. So I represent Defense Research and Development Organization, which has a theme, Balasya Moolam Vigyanam. It is the science which is the force behind the strength. So the topic of today's presentation is transforming challenges into opportunities for self-reliance in defense technology. Now, this self-reliance is something which has been talked about for quite some time. India, as you would be knowing, I mean, it has been listed at many places that we have been importing systems for quite some time. However, it is time to actually change that or turn the tide and have self-reliance in critical defense technologies, which have huge internal requirements are huge, as well as it has huge export potential. So if you look at it from both the perspective, that is giving the strength to the country, as well strength to the country in terms of military terms, as well as in economics terms. So this has a huge area of exploitation, which is awaiting actually, I mean, to be participated by the technocrats, by the industry, by the academic institutes of the country, along with the R&D institutes. I will be covering my presentation. I'll be talking naturally a little bit about DRDO, which is a part of Department of Defense R&D under Ministry of Defense. I'll also apprise you about my laboratory, the Terminal Ballistics Research Laboratory. Then how do we perceive self-reliance? People will have different connotation, different definition for this. The way we perceive is what I will try to bring out. Then coming to the challenges in defense technologies, then our capabilities and the opportunities. DRDO is the Government of India's premier research establishment for defense technologies. It is having 7 technology clusters, and DD-R&D is the parent department. DRDO is one of the constituent of the parent department, DD-R&D, which has 7 technology clusters involving about 43 laboratories spread all over the country. We have 6 corporate clusters, which is based at DRDO headquarters in Delhi. 4 HR institutions, which specifically takes care of the training requirements as well as the career growth requirements of all the scientific and the technical staff in this organization. There is a separate society, ADA, the Aeronautical Development Agency, which is involved with the development of fighter aircrafts, which is a part of DDR&D. BrahMos is a JV, which is developing supersonic cruise missiles. DDR&D also has 2 certification agencies, one for airworthiness of any flying stores, and second is for the software, and a specialized institute, a deemed university, to train our scientists in armament technologies. As on date, DRDO has around 7,000 plus scientists in its portfolio today in various disciplines of engineering and sciences. Just to have a brief glimpse about the journey of DRDO. DRDO started in 1958. Sorry, the system, the presentation is a little skewed because of the sudden font change between 2 different platforms. We started in 1958 as an inspection agency with a laboratory strength of 10. Now we have grown to a laboratory strength of 43 with a manpower strength of 20,000 plus. And initial years, as expected in any scientific organization, R&D establishment, it was basically to establish the core research area, develop the technologies, convert it into design, take it to the prototype, and then go for the trials. And as you would be very well aware, that a defense technology actually has a large gestation period, and therefore the initial era actually was more of a technology development, the scientific knowledge, creating the environment, creating the ecosystem, and then 2000 onward, it is more of a that all the technology consolidation is actually resulting into the systems and platforms. So, but one point which has to be seen also is anticipating the requirements of future. There were certain programs which were conceived at that point in time, 1980 to 85, when IGM-DP, which is basically the backbone of a missile development program in the country, and the MBT, Arjun, that is the main battle tank for all the armored fighting vehicle. That program were taken up in 1980 to 85, when the technology gaps were there. Industry also was coming up. However, in order to anticipating the requirements that will come, these programs were taken up today. If we have reached a level of maturity, it is because of this anticipation in future, which actually is one of the challenge that I will be coming in subsequent slide. How do we actually look at what would be required in future? DRDO has many systems where it has demonstrated capabilities, and it is at par with any other country in the world. Various types of missiles. You can talk in terms of surface-to-air missiles, surface-to-surface missile, long surface-to-air missiles, air-to-surface missiles, air-to-air missiles, any type of missiles. DRDO has full capabilities and different kinds of bombs, gravity drop bombs to the glide bombs, long-range glide bombs. All kinds of capabilities are there with DRDO. The fighter aircraft in terms of LCA Tejas has already been inducted in the armed forces, and the upgrades are being carried out. All types of radars and the sonars, the basic sensors for any in a warfare scenario, that has been our core competency. The torpedoes and decoys for naval applications, the electronic warfare systems, the armored fighting vehicles, whether it is a wheeled or tracked, and the guns and the rockets. Incidentally, the world's largest range gun, the ATAGS, has been developed by DRDO along with our industry partners, which is firing to the maximum. It's better than world's any other long firing guns today. All the rockets, Pinaka, you must have heard about it. Pinaka has been developed by DRDO, now is being produced by industry for the requirements of armed forces. And there are many other areas where DRDO has got systems with demonstrated capabilities. Now, coming to the laboratory that I represent, Terminal Ballistics Research Laboratory in Chandigarh. TBRL, Terminal Ballistics Research Laboratory, is a part of the Missiles and Strategic Systems cluster, technology cluster of DRDO. And TBRL specializes in development of technologies for the penetrating warheads or the shape charge warheads and the EFP technologies for defeat of armored and naval targets. Another area that we have very strongly working on is the high energy, high pulse power systems, which is actually driven by the explosive for the magnetic flux compression for EM generation. Then the small arms firing practice generally is carried out in open. We have come out with a concept where you put baffle on ground so that the total firing area requirements comes down from around 300 to 500 acres to about 5 to 20 acres, depending on the range, without compromising on the practice requirement of a soldier. Then major conflicts are, of course, there, but side by side, the low intensity conflict also is there, very prevalent in any society nowadays. And of course, you cannot use the similar kind of systems, what is generally used for military applications in low intensity conflict. Accordingly, the munitions need to be developed for that, which TBRL has developed. Then all types of electronic fuses, whether we talk in terms of any shells, bombs, any warheads, they are always initiated and detonated with the help of electronic fuses. Most of the fuses were imported. Now we have established the enabling technologies for the fuses. Also, transfers of technologies have been done to the industry actually for the manufacturing of these fuses. Another area of core competency of TBRL is the test and performance evaluation of all types of warheads, bombs, and shell. We are the only static range in the country where these kind of trials can be carried out. The blast protective systems, whether it is boot anti-mine, which is basically used by the deminers, the mine-protected vehicles, gears, or the blast doors, basically to protect any structure. All their evaluation using explosives and creating the blast wave is done here. The ballistic evaluation of body and vehicle armor, which is all the bullet, we call it bullet-resistant jackets and ballistic helmets, all glasses, which is offering protection against small arms attack. Their performance evaluation under laboratory condition also and also by accelerated aging of the armor to see its efficacy at the end of its service life. In any defense equipment, you have to always be very sure about the service life of that equipment, and you have to create conditions in laboratory to make sure that the system performs even at the end of its life cycle in the similar manner as it would have been doing in the initial stages. No degradation in performance is expected for that duration. Then we have specialized test facility to test various subsystems or systems depending on its weight and size, of which are basically carried by the missiles and airborne. We create the similar conditions as an object would be facing in flight conditions, in a free flight condition. We create those kind of conditions in the laboratory and test in both recovery mode as well as in impact mode, the performance of the subsystems. Also, in order to meet all our design and development requirement as well as test and performance evaluation requirements, we have a captive high explosive composition facility, processing facility within TBRL. We can develop various kinds of explosive formulations. All the systems which we are developing, we develop the explosive compositions and the related technologies ourselves. Insensitive formulations have been developed. Also, we have the facility to do casting of explosive like any other metallic casting, cast cure systems like a polymeric system, and a pressed, that is, using it as a hydraulic press or a mechanical presses. And you can do the pressing of the explosive followed by the machining. This actually makes it very interesting because explosive generally looks to be a very tough material, but it is amenable to all processing as a normal metallic or a non-metallic material. The key test facility is the RTRS, the Rail Track Rocket Sled National Test Facility, where I was talking of creating the conditions on ground, simulating the flight conditions. We can create, as you can see, there are 5 rails parallel to each other of about 4 kilometers long, and we can carry up to 1000 kg at supersonic speed. If we have reduced the weight to about 150 kg, we can go to Mach 2. On ground, create the dynamic pressure as expected in a flight condition and allow the systems to perform as expected in a flight condition. So this actually helps us to, without actually going in for the very time-consuming and expensive flight trials, you can actually verify this performance, system performance on ground, make design corrections, validate your simulations, and then go for the final trial. So reducing the burden on carrying out the system level trial and therefore reducing the cost of development also. Another facility which we have is typically, generally when we talk in terms of impact velocities, in case of automobile, it will be of the order of about 30 meters per second at the worst, at 30 meters to 40 meters per second. However, when we talk in terms of defense application, we are always talking in terms of ordnance, subordnance, and hypersonic or supersonic speeds. Generally, the ordnance velocities will be of the range of about 800 meters per second. However, in this particular case, when we talk in terms of relative interaction, because of the relative velocity of the two very fast moving objects, the velocity can go to even 2 kilometers. And in certain cases, Like, when we talk in terms of space debris, it can go even up to 8.5 kilometers and beyond. And you have to actually design your all your space shields, all your protective systems to withstand that kind of a meteorite impact or a space debris impact, basically, and which is low mass but very high relative velocity. So those conditions can be created using two-stage light gas gun in laboratory, and see the effectiveness of the protective shields that are provided on the on any object in space, going in space. For more traditional application, we have fragment launching guns, which is more for ordnance applications or armament applications, going up to 40 millimeter caliber and velocities of 2 kilometers per second, which actually you can create a relative velocity scenario or a direct velocity scenario by controlling the propellant in the gun. Then for more characterization of the materials, because the material behave very, very differently in a quasi-static condition and in the dynamic conditions. So in order to ascertain the properties and the characterization of the material under very high strain rate conditions, we have specialized test setup where we can go up to 10 to the power 4 per second. Then environmental test facility, because any military equipment is supposed to withstand varied temperature conditions, vibration conditions, and EMI/MC conditions. So you have to test all these equipment in lab before they are certified for field applications. So all those facilities are there within TBRL. Then to carry out the blast and or the performance evaluation of the shells, bombs, and warheads, we have arena layout where we can detonate up to full-scale warhead in TBRL and look for the mass distribution, fragment velocity distribution, also the blast pressure measurement, which comes associated with any explosive that is detonated. Then to carry out this small arms testing, we have an instrumented ballistic range wherein the body armor can be tested as per the prevailing international standards. And now a national standard also has been developed for the testing of bullet-resistant jackets, wherein TBRL was one of the major contributor in development of that national standard. Then also we have very specialized photography team, which actually captures all the transient events. And for us, a millisecond is a very, very slow phenomena. We talk in terms of microsecond and nanosecond. That is our usual time range for recording. Then specialized instrumentation to actually assess the performance of any system, a protective system or an offensive system under the effect of blast and damage. Specialized flash radiography system, which can actually see through the detonation cloud, which otherwise normal camera cannot see, so that you can actually study the explosive metal interaction. And modeling and simulation of transient phenomena, that goes hand in hand, because we cannot afford to carry out that many number of trials unless we must be in a position to simulate with a high fidelity and reduce the load on carrying out the field evaluations. Some of the products that TBRL has developed, which has gone to the Indian Armed Forces, the multi-mode hand grenade and the bun blasting device. These are the two of the products which have already been handed over to the armed forces. Other than that, we have less lethal plastic bullets, then the exploder, the initiating systems to initiate the torpedoes. HMX is an explosive particle which is considered to be the most powerful as on date. For various applications, we actually modify the particle size. So for one of the civilian applications, as well as for the application in propellant industry, finer particles of HMX has been developed, which has the TOT has already been given to the industry, and it is under commercial production now. For the fuse, for the multi-mode hand grenade, we have developed pyro delay-based fuse, as well as a mechatronic fuse for a very precise control of all the delay timings that we want, and then all the electronic safe and arm fuses for different applications. So these are the products which have been developed by TBRL, and the technologies have been handed over to the industry. And when we talk in terms of industry, it is private industries are also a part of that. Not only on the DPSUs are doing the production of armament systems now, it is the private industry which is actually also contributing in a very, very big way. Incidentally, this multi-mode hand grenade is one of the first ammunition which actually has been produced by a private industry and handed over to the armed forces. Otherwise, till now, it is only the Ordnance Factory Board which we are producing. So this is basically one of the change that has happened in recent times. So now coming to the self-reliance, as we perceive self-reliance in defense technologies, we look for design and development capabilities. And the moment we talk in terms of design capabilities, we need to have the basic applied and translational research capabilities in-house. That in-house, when I say it is indigenous, always in-house is always within the country. And the knowledge repository, we understand it has to be there in the country, and the most, you can say, the most appropriate place for this knowledge repository is the academic institutes of the country, where a continuity in terms of research activities can be maintained. And that is where the world over the systems have evolved like that. The knowledge repository has always been with the academic institutes. And at the time of applied and translational research, the R&D institutes come in picture, and then subsequently the industry takes over. So there has to be a network of all these agencies together for formalizing the design and development capabilities in the country. Design and development, traditionally, we have been a very, very strong nation as far as design and development capabilities are concerned. Our design capabilities are no less than anybody else for any of the systems, including the most complex ones. However, manufacturing also is one area which requires attention. You require very precision and complex machining capabilities. You require all high-end materials and its processing capabilities, various devices that need to go in any complex system. Now, unless we can have a design capability, but if we are dependent on imported materials, imported devices, that is not going to be a good situation at any given point in time. It is always better that a back-end integration also is carried out in terms of manufacturing capabilities. Then assembly and integration and testing. However, assembly and integration also is a very, very skillful job. And because this is the time when different systems manufactured by different agencies, they come together, and their interfacing issues actually come up only at this stage. So it requires huge amount of skill actually to do this debugging operation when you are actually combining many systems with different interfaces, different performance requirements and expectations. So requires a huge amount of skill to do this. Secondly, the advanced test facilities, because all these defense equipment, they are not run-of-the-mill kind of a thing. You need to have specialized test facilities meeting specific requirements of different systems. These are very, very capital intensive, and other than the capital intensive, they are very, very skill intensive, because it is basically it is at this place actually that the difference between a good product and a not so good product actually comes in. If we are able to control the infant mortality rate at this point in time through our test mechanisms, that you are going to have a much more better, reliable, safe, and a system which performs even till the end of its life. In defense equipment, always you have to consider that if a shelf life has been given to be 15 years or 20 years, the item may remain on shelf for 20 years. But on the 20th year, also, if it is required to function, it must function with the same intensity, same performance level as on day one. So therefore, such kind of a testing and having that kind of a confidence that at the end of 20 years, it will still sustain, that is very, very essential and requires huge amount of knowledge and skill and technology skills, basically. Then military equipment, as you know, is a very, very capital intensive game. And therefore, it is not that easy that we keep changing the systems so fast. There have to be upgrades. So in order to have upgrades, you need to have your design control. Otherwise, on any bought out system, whatever upgrades we may do without actually understanding, it will remain as a black box to us. If we do upgrades, it may result into a patchwork kind of a thing, which some point in time may not yield you desired results. So in order to have the upgrades, in order to save the cost going out of the country, retaining it within the country, we need to have the design control within the country. And life cycle management, as is expected in any of the equipment, capital equipment, you need to have the life cycle management, obsolescence management. And unless we know what is to be changed, when it is to be changed, how it is to be changed, without actually compromising on the performance, without compromising on the safety, it may not be resulting into a very fruitful situation where we are totally dependent for the spares on somebody else. So this is how I put in perspective of self-reliance. Sorry. What is it happening? Yeah. Now coming to the challenges. I'll define the challenges in two operational scenarios. First one is, in any kind of a warfare, first and foremost thing is you should not get detected. Have that kind of a capability that you are in hiding in a good sense. People should not be able to detect with their most advanced sensors. And if you get hit, if you get detected, you are likely to get hit. So first one is don't get detected. In case you are getting detected, make sure you don't get hit. That means you should have the maneuverability, a fast moving, changing position capability. Don't get hit or have a protective layer. Third is, in case you get hit, you must survive the hit in order to hit back. So that means, your protection mechanisms need to be very, very strong. You can put it in terms of these things you can actually generalize in terms of either cyber attacks or in terms of information technology or in terms of a direct conventional way of warfare. That is traditional with different kind of munitions. So these are the basic things. One operational scenario that you can consider. And the second operational scenario is this was when you are actually in a defensive mode. Now you come to the offensive mode, which means you should hit him before he detects you. Because it's not that the opponents do not have detection capability. They also have some kind of good detection capability. So you must have something better that you hit them before you get detected. Other point I say, you should survive the hit. Now you, as an offensive, you should have the hit capability, which is beyond survivability. Then only you can inflict the damage and the opponent cannot hit you back. And the third is, and which is actually now where the world is now leading with the network-centric scenario, you should detect and disable the C4 ISR of the enemy. And this actually blinds or make his network-centric system out of order for some time or a longer time, enabling you to take either option number 1 or option number 2. So these are all the major scenarios if you look from offensive applications and defensive applications. So this is as far as the operational philosophy or the scenario is concerned. Now you translate it into challenges. If you try to combine, and these are not in order of priorities, these are just as I have listed out, and people can actually change, have their own priorities in this case. It is always, the defense technologies is always a race between the offensive and the defensive capabilities. The offensive is becoming more and more potent. Defensive is becoming more capability to withstand that kind of attack with much less mass. So this is basically a game which always keeps on going. So the major challenge is that you need to have speed. That means before the enemy detects you, you should be able to reach him. You should have a range, because every sensor system will have some capability, some range capability. You should be beyond that. You should have a range capability which is beyond the enemy sensor's capability, a precision, and a higher lethality. Precision means you hit the point which you want to hit, so you don't do the collateral damage. And higher lethality means hit him beyond survivability. Now, if you look at the requirements, because other person is also monitoring you, so you should need to have the mobility and the response time, which means you should have very quick response time. If you feel that target is there, you should be able to hit him back. You should be, after hitting him, you should be able to move away from that location, so that if he is not able to get the signature back. So this actually puts different kind of requirements and challenges on the technologies. At some point in time, you need range, which means you need more propulsive power. At the same time, I need to have a very high mobility, which means the propulsive power need to give that kind of a thrust, but with much lesser mass. Similarly, the speed, which means the way traditionally we carry the oxidizer and the fuel together, can we separate it out in order to reduce the weight of the vehicle, so that to increase the speed. And these are all, when I have not specifically intended the technologies or various specific systems, but I have tried to generally cover it in a broad spectrum of technology areas, because the products will always follow the technology areas. They will have multiple applications. So I'm more focusing on technology areas. Systems will have network-centric, and at the moment you talk in terms of network-centric, the two different kind of systems operating on two different principles, two different interfaces. They need to be together without, one fellow affecting the other. Second, you should be You should not be jammed by others. You should be able to jam others. So what you have put as your offensive mechanism actually need to you have to protect your system against that also. Then sensors, whether we talk in terms of radars, sonars, or any other type of sensors, because the range, the farthest you are able to detect with the smallest size, the better it is. But in order to have range capability, naturally the size becomes a paradoxical requirement, which means you need to have a very high TXRX modules in the sensors or any other kind of a sensors. Then the primary thing that you are looking at sensor is not its capability only to detect. You can detect an object, but you have to also identify which object you are looking at, because you cannot keep looking for all kinds of targets. You have to look for certain classified targets. And once having classified the targets, you also have to know, because in a war scenario, it is always the friend and foe almost in the near vicinity of each other. And you have to also distinguish between the friend and the foe, so that no fratricide should take place. So you should be able to only take a target which is a foe target and not never a friendly target. Then the materials, that is one area where a lot of work need to be done in terms of its processing. All kinds of material, whether it is metallic materials, it's a composites or a polymeric materials, and our own control on the process, the raw material processing, its characterization for different applications, and its manufacturing from very small scale to a very large scale engineering products. So these are some of the challenges that are there today. Then when we talk in terms of speed or range, the propulsive power comes into picture. And predominantly the propulsive power, if I leave apart the aerospace platforms, the aircrafts and others, the prime mover basically for all range thing is basically the energetic materials. We are using all conventional energetics, and people are now talking in terms of green energetics, because when you do the burning, combustion or detonation, it is sometimes your own area also which is getting affected. So can we have green energetics? So the moment we talk in terms of green energetics, are we compromising on the energy part of it? We need to have, at the moment, we need to have a smaller system, more flexible, more agile system. We need to have very high specific energy of that energetic molecule. The moment we talk in terms of very high energetic molecules or the higher specific energies, the stability of the molecule comes in picture. And the molecule also, once we have taken the molecule, converted into compounds and formulations, it need to remain stable. So if it is not stable because of its energy content, it's self-degrading. That also is a challenge. So we have to have always a trade-off between the stability and the energy content between the energetic compounds. Then the protective technologies, whether we are talking in terms of protection of the personnel or the armored fighting vehicles, we can always protect given the weight and the volume. But that is not the case in particularly in defense technologies. There is always a compromise. If we say a soldier can be protected against a small arms fire with a protective weight of about 10.5 kg or 12 kg or like that, yes, he can be protected up to a certain extent of small arms ammunition attack, but it very strongly affects his mobility. And his own, if he has to be on offensive with such kind of an additional payload, his mobility is affected. Secondly, he has also a carrying capability. So if he carries 10 kg of protective gears, he has to carry 10 kg less of his own fighting material. So this is a trade-off that you have to look at. So when we talk in terms of protective technology, it is always we have to compare it against the protection is afforded at what cost, and the cost is in terms of the weight of the material. Which means, the moment we talk in terms of weight, the specific density comes into picture, the mass per unit volume, this total protection afforded per unit volume. That is what we will consider. Then the standoff technologies, hit before you get detected, which means you need to have long range capabilities. But when you talk in terms of long range capabilities, particularly directed energy systems and other type of things, you also have to make sure that you should not inflict damage on yourself, which means your protective mechanism against such kind of standoff technologies also need to be equally strong. Then another feature that is being talked about is you don't get detected is stealth, how far you can keep yourself invisible from the eyes sensors of your opponent. So various technologies are there. the more you are delaying your detection, more potent is the weapon. That is how you can put it. Then soldier as a system, every time we are talking in terms of various kind of technology systems, till the time we are going to the fully autonomous systems, it is the soldier or the person who has to take the decision, and therefore we also have to consider him as a system and ease out on his working. Or one of the examples can be that if he has to go on a mountainous region, can we reduce the load that he carries by providing certain other setup which actually shares the load on the human body, or some kind of a detection mechanism where a soldier, wherever his position is, his people know where he is, so that in case of a difficult situation, he can be taken, he can be helped out. So these are his protective gears. Everything actually as a system, as a soldier as a system is being now one area which is being worked upon. Then when we talk in terms of modeling and simulation, high fidelity model, which is true representation of the phenomena, because in most of these cases, these are all destructive tests. So getting anything out of that, sometimes it becomes very challenging. So the results, these are dependent on the confidence that you have in the true representation of the model. Like typically we talk in terms of protective systems on human, the human body model becomes very, very essential, because anything wrong that goes in this simulation here will not yield the desired result and may have some kind of an injury to the person actually. So the modeling and simulation, human is one. Any other engine, other systems like an aircraft or a missile or any other system also requires the similar kind of high fidelity models to do the simulation to get the near value of what you will get in the flight conditions. Then only the test results and the sensor deployment during the test actually becomes more meaningful. Then you need, for any defense equipment, you need very specialized test infrastructures and facilities. Some of the examples are wind tunnels, which can be in for all the velocity regimes. Then the RTRS type of facilities where you can create the same cap condition or flight conditions on ground and reduce your number of trials, reduce your actual trials, thereby bringing down your development cost, and various test and proof ranges. And at the end of it, military technology or any other technology is generally cost prohibitive. So how it can be made cost effective? More, if you can make it more cost effective, you can actually employ more number of systems, or the other way is you can actually use this kind of money, what otherwise will be spent here, on other societal aspects, including the R&D aspects. And always we look for in defense equipment for a very long operational life and low life cycle management or near maintenance free management. Of course, these are the all these requirements are always paradoxical, but that is the challenge. How whatever we can actually afford to do here, wherever we can improve, we actually improve directly into the ecosystem. This is basically these have direct impact on the ecosystem for defense equipment. So just summarizing the challenges in terms of defense technologies, we always have to be better than adversary at any point in time. So you need to have knowledge about what your adversary has or potential to have, and accordingly you have to have a system which is anytime better than their system in all the operational scenario conditions. Secondly, the technologies are fast obsolescing in today's time. Obsolescence is very, very fast, and particularly with the devices, with the computing systems. And it is always a race against time that the system that you configure for, you should be able to employ it before the technology becomes obsolete, because after that, life cycle management becomes a costly affair. And naturally, a new technology comes. So old technology nobody wants to have with themselves. Third is for all defense equipment, we have a defined user who is very, very active, who is very competent, extremely knowledgeable, and therefore they are demanding, which is absolutely right in from their perspective. And therefore we have to always be on our toes actually to meet these requirements. Now, looking at the geopolitical situation and outside, you also have to look at the changing environment and set perception. And when we talk in terms of changing environment, it is also, we have to look at the capabilities of our stakeholders, various stakeholders who will be associated with us. The threat perception is external. Changing environment can be both external as well as internal. And like I said in my initial slide, when we talked of DRDO's work starting in 1980s, the technology forecasting, that is, it's a very, very difficult job, but this is something which actually differentiates between what you will have is better than your adversary or no, or how you are able to give time to the academic institutes, to the R&D institutes, and to the industry to graduate from where they are to meet the futuristic technology requirements. And one of the most important thing is you have to imagine what the future warfare is going to be and accordingly be ready with the technologies. At some point in time, certain things were not considered as a warfare mechanism. Today, information technology has come out as a very, very strong system in that. A cyber warfare system has come as a very potent warfare mechanism. So similar type of things may come in future, and therefore you have to have both R&D capabilities and system development capability in offensive as well as in defensive applications. So whenever we talk in terms of defense technologies, it is never that one side has to be looked at. It is always we have to look at both the defensive capabilities and the offensive capabilities. So we have to imagine, think what is going to come in times to come and be ready with that. Be geared up, have that period of this 5, 10, 15 years to build the knowledge base, build the industry capability, and then be ready with the system as and when the time is right. So now coming to the opportunities. Yeah, coming to this opportunities, we are now evolving as an ecosystem. If you look at Indian scenario, we have 4 major partners, starting with the armed forces, which basically they put out the requirements as per their own perception of threat and their operational philosophy. And also, this is the agency which actually carries out the test and evaluation also, because they are the one who are going to employ it in times to come. And now DRDO does the technology development. There is a general perception that DRDO does the manufacturing, but DRDO only does the technology development and takes help of industry for manufacturing. We do the system design and development to ensure the performance and also support the industry in many ways to develop the industrial ecosystem. The academia, we are looking at academia to develop the skill and the knowledge base and carry out the research in the technology readiness levels of 1 to 3, that is the basic science as well as the applied research part of it, and industry to manufacture the prototypes and also go for the production and life cycle management. Now, with the involvement of all agencies and in the evolving ecosystem, the industry is in a position to take up the life cycle management and upgrades on its own. The technology support from DRDO and academia is also going to be there. In earlier times, it used to be a very linear kind of a geometry, linear from one agency to other agency. Now it's a very, very crossing of boundaries, wherein armed forces is also engaging with the industry. The industry is also engaging with the academia to create its own knowledge base in technology areas. DRDO is collaborating with all the 3 of them. So if you look at the total ecosystem, these 4 are the pillars for the evolving defense ecosystem in the country. Next. How DRDO is engaged with this, I'll just try to cover up in about next 5 minutes time. Academia, we have 10 Center of Excellences in various academic institutes in the country in various specialized areas. DRDO is supporting the research with the academic institutes in 2 different manners. The extramural research, where the academic institutes initiate the proposal suo moto and in potential areas and defense requirements, or it may not have in the initial stages, it may not have a defense requirement. And once the technology is developed, then we can look at defense applications. So both these modes, we are in a position to support the industry, academic institutes to take up projects. And 4 research boards in DRDO are operational: armament, aero and naval and life sciences, specific to these technology clusters. Specific problems can be given to the research boards, which grants the funds to the academic institutes to take on the research. It can be in the basic research, it can be in terms of applied research. At this point in time, more emphasis is on basic research with the academic institutes. The first one, extramural research, is for something which do not have a direct defense application at this point in time. However, when we have certain specific academic problems, when we are handling a project, we generally go to the contract for acquisition of research services, CARS, wherein specific technology issues with a short timeline is given to the academic institutes, and that is being worked upon. The output of these CARS directly go into the projects. The first one may become as a knowledge base, knowledge repository. The second one has a direct application in the systems. And both these things are very, very strong in DRDO. As far as extramural research and CARS are concerned, put together, we have almost about 1,200 ongoing projects, and the exposure is more than about 1,200 to 1,300 crores at this point in time. Next. Then another initiative that has been taken recently, this has started from the previous academic session, the MTech in Defense Technologies. Many universities, many institutes, they have started this MTech in Defense Technologies, wherein the students, they have the project, the coursework they carry out in their institutes. For the project work, they can come to the DRDO establishments. This is to create a skilled manpower in the country who can be employed either in the industry also, because as of now also there are no specialized training programs or in the country in defense technology areas, and therefore the industries also have to take people and then give them specific training. So this also is going to be useful for all industry who is now involving into R&D for defense technologies and into the production. So that way the skill level of manpower is going to be higher for industry also. So that is one initiative that has been taken now. As far as the research scholars are concerned, we have come out with a scheme where 500 research scholars from nominated at different universities, academic institutes, they get registered at their respective institutes and can carry out the research work on a live problem pertaining to a DRDO establishment in DRDO lab. So they can utilize the facilities at DRDO establishments, labs at DRDO establishments, and carry out their own research work, which has got bearing for defense application. That also gives them a better opportunity to have as a developed, highly skilled manpower for industry to carry out R&D work in industry or in DRDO as may be the case. In order to just 6 months training to students in engineering college, there is a mechanism of internship where a small project is given to the students. They come here to the lab, work in the lab for 6 months, and as a part of their coursework, they are doing this. On an average, if we look at about 500 research scholars are there now nominated for DRDO work, and in a year, in DRDO we have about 4,000 students who are actually getting internship at all over the labs in DRDO. Next. How we are actually in creating supporting the environment in terms of providing R&D support to the industry. Today, DRDO has 2,200 plus industries as partners, and these are all major industries who are supplying subsystems and big components or products. If we look at smaller components or subsystem or basically in the supply chain of subsystems, we have about 13,000 industries in the country. The industry, initially, it was on BTP basis, that is built to print. We give the design, everything, and the industry only manufactures. That was the original concept. Now, the industry also has graduated to that level that once the problem statement is given to them, they are in a position to define, they are able to do the design by themselves and have migrated to build to specification. And the objective is that the industry should migrate to build to design. That is, they conceptualize something with their own R&D base supported by the manpower, the skilled manpower that is now going to be available. They should take up build to design projects on their own. Now, this year, you might have heard and might have come to know that 25% of defense R&D budget has been earmarked for industry, startups, and academia in order to support the R&D activities in the industry. And there are various schemes available on these can be actually accessed on the MOD website also. Another model that has now been proposed, earlier times, DRDO was doing the technology development, and at the end of the technology development, we look for industry partner and do the transfer of technology and then start the production. So it was a very serial kind of activity, taking a lot of time. Now, another thing is that point is why at this point in time, initial stages itself, form an SPV wherein the private industry and DRDO come together, harness the potential that is the industry's manufacturing capabilities and DRDO's test and evaluation, design and development and test and evaluation capabilities, and put them for the design and development of military platforms. So this is another proposal that has been given in budget, directives that have been given in budget, and which is being worked upon very seriously now. Another one is to support and boost the research and development capabilities in the MSMEs and the startups. The Technology Development Fund is now supporting them in a big way. A scheme of 150 projects actually have been worked upon. Proposals are being worked upon. I think about 60 are already sanctioned and rest are in different stages of sanction. Industry can be supported with 10 crores budget, up to 10 crores of budget, with 90% funding by the government, 10% by the industry. And the startups can also be funded up to 1 crores. These can be taken up on the suo motu proposals of indigenization of different imported components or products, or also on a product or a problem statement given by the armed forces or by the DRDO. So all the details will be available on the TDF website. Next. In order to, at one place, we are talking in terms of SPVs, that is for the bigger systems and platforms, but for other components, subsystems, or smaller systems, we are now, as an integral part of our development process, we are going in with the development cum production partner, just to cut down on the serialness of the production design development cycle to the production cycle. So the development agency gets involved right from the start of the development process. So the industry also grows in confidence along with us during the development phase and is production ready. So that actually cuts down the total time of migration from design development to the production to handing over to the user. Some point in time, a very nominal TOT was charged at a rate of 5% of the development cost. That also is now waived off for the agencies, industry partners who are selected as DCPPs. So that's a good boost to the industry to participate as a development cum production partner. And as per the DAP procedures, the industry nominated as DCPP, they will be placed orders directly by the armed forces based on their requirements. DRDO is right now holding almost many technologies, out of which 1,400 plus technologies have already been transferred to more than 550 industries. Some industries have taken more technologies depending on their work area. And when we provide the transfer of technology to the industry, the total hand-holding support in order to ensure the production at the industry level is also provided by the DRDO. Any upgrades that may happen in the residency of TOT is also supported by DRDO. Various test facilities, and we have many of them in DRDO. All the test facilities are now being made available to industry, of course, on a nominal charge basis. But now the industry need not set up all these specialized and capital-intensive test facilities by themselves. They can make use of the test facilities available with the DRDO. Also, the DRDO patents are now being made available to Indian industry on nil cost basis. So they can actually benefit directly from these patents held by DRDO for their products. Next. To support innovation, we are now working on a concept of Dare to Dream, the Dare to Dream version 3.0. The nominations or the submissions have just been completed. For every year we are holding it, where we are actually promoting the individuals, the researchers, and the startups for innovation in defense and aerospace. Various problem statements are given, and everybody is actually encouraged to participate in that. As of now, we had till in last two versions, version 1.0 and 2.0, we have almost 4,000 people who have actually participated in such innovation. There is an award scheme for the selected contestants, and also some of the selected contestants have been given grant to develop technologies and prototypes. So this is basically to support any individual who has an idea meeting the requirements of defense technologies, can be supported in many, many ways. There are many mechanisms available to support either the individual, any researcher or a startup, and the MSMEs to actually take up R&D work in their own area to be supported by government agencies. Next. So with this, I conclude my presentation. Thank you very much, and Jai Hind.
Thank you very much, sir. It was an amazing session, very insightful about how we design bombs and shells, and about the working of DRDO, and the real life challenges that we face in a real war field. We would now like to take up some questions from the audience. Uh,
Sure.
I'll be reading them to you one by one. First is by Rupesh Kumar Rajan. Does self-reliance refers developing bioweapons too, or we should not turn towards bioweapons and just focus on mass destructive weapons or one-time burst?
I'll rather try to answer it this way. Let us focus on technologies, and don't look at the product at this point in time. Once the technologies are there, you can actually use it for any of the product. And let us not be very specific about any kind of weapon systems. I'll still re-insist on that. Have the competence in developing the technologies. Once the technology is there, you can convert it for civilian application. You can convert it for defense application. Technology has no boundary. It has no regime, you can say. So you can, once the technology is in your control, you can put it for civilian application. Why always to look at such kind of offensive applications? You can have in both the job. Yes, defense is also important. Defense is very, very important. But at the same time, if it has potential for civilian applications, please go for that.
Yes, sir. Thank you, sir. Next is by Srinitya. What are the challenges faced by defense sector in India in its pursuit of self-reliance?
I think all the challenges that I listed out in one of the slides, I think you can take that. To start with, materials, then devices, various kinds of devices, the sensors, I mean, the miniaturization of the sensors, then this high fidelity models, simulation capabilities, some of the very specialized test facilities, because many a times, I mean, the test facility is not there, so you get delayed in development. So these are basic issues that are being faced on. They are being worked upon. We have created many of the things indigenously with our own resources, with our own knowledge pool, pooling together academic institutes, industry, R&D institutes like DRDO and CSIR and many other agencies. So we are moving towards it, yes, but it's a very capital intensive and a very knowledge intensive. So some places we have gaps that are being worked upon.
Yes, sir. Thank you, sir. Next is by Shambhuvi. How close is the current generation laboratory simulations for testing weapon technologies when compared to the real world testing environment?
I'll say we are comparable. I'll not say we are very bad. We are much off. The simulation capabilities in the country is as at par, you can say, at par with what the world has.
Oh, that's great, sir. Next is by Manish. So is DRDO also working on the indigenous production of defense and offense systems that will work without any or minimal human intervention? Is decision taking as well as in battleground?
See, one is that will work with okay. No, I'll just see. When I said, I mean, in the operational scenario, don't get detected, or even if you detect, you should have capability to absorb. So we are talking in terms of both defensive and offensive systems. That is one. Secondly, we are also talking in terms of systems which are where a human intervention is brought to the minimal. That is, take maximum advantage of AI, ML, and all your cyber capabilities, network-centric capabilities, and make make a system which is autonomous with all the data that it requires to take decisions on the battlefield. That is where actually the world is heading to. These are the systems that will be worked upon in future. Yes.
I hope that answers your question, Manish. We'll be taking up our last question, which is by Srinivasu. I have a doubt that today youth are not showing interest on this defense and national issues and searching for the jobs which are having fun, like working for corporate. What do you say about it?
A very pertinent question, I'll say. Uh, See, you look at defense has its own challenges, and any technology area, why defense? Any technology area that has its own challenges, and it is not as fast result yielding as a normal corporate job would be. I'm not, undermining anybody, either corporate or defense or any other sector for that matter. But there, the results are fast to be seen.
Yes.
Here, it takes a lot of time actually because you have to do a lot of analysis, and it requires a lot of patience. Perseverance is one of the most important thing actually when you're looking at defense technology. So people with that kind of, if you are looking for challenges in terms of your engineering skills being proven in front of your eyes, I'm quoting that word, proving your engineering skills, getting proven in front of your eyes, high-end technology areas, including defense, is the area to go for it. But using your knowledge for any other application, that's an individual choice.
Yes, so I also
But
think that it is like how people choose about what they feel more about whether it is they like delayed gratification or instant gratification. Like people preferring instant gratification go for corporate jobs where they can see results instantly, and otherwise they can go for
generally, any defense system you say it requires a total development cycle time from conceptualization to the product realization to the induction in the armed forces and usage. And for its total life cycle, if you look at the total life cycle is about 50 to 60 years, in which about 5 years will be in the concept formulation stage, proving stage. Another 10 years is from prototype to production stage. So for a complex, I'm talking
Yeah.
of for a very complex system like a fighter aircraft. You take
Yes,
world
sir.
standard, everybody has taken about 15 years or so, and on average, around 15, 17 years. And we have also taken almost the same time. So these are the issues, yes. But it is all, I'll say, engineering skills. If it is employed for engineering applications, that is
Yes,
that
sir.
is how it should be. That's how I will
Yes.
put it.
Yes, sir. Thank you very much, sir. We were very glad to have you.
Thank you. Thank you very much. Thank you. It's a pleasure. Thank you.
Thank you. Thank you very much.